A group of 5 friends has 2 tickets to the ball game. How many different combinations of these 5 friends can use the tickets? Okay, this is also a counting problem. It's requiring us to count the possible number of ways or combinations to arrange these tickets, which is really a fundamental basis to learning probability, because in probability you have to find the number of ways an event can occur divided by the number of possibilities in total. So with that, let's begin to look at it. Most students learn the following approach to a problem like this. If I have 2 tickets, call it ticket 1 and ticket 2, right? We'll just call it ticket 1 and ticket 2. First ticket, we can give it to any of the 5 friends. So there are 5 possible ways to give the first ticket. The second ticket, there will only be 4 friends left. So I can give that ticket in 4 different ways. And the total number of possibilities or possible arrangements of those 2 tickets being given among the 5 friends is therefore 5 times 4, where the count of event 1 times the count of event 2 equals the total count. In this case, that's 20. But again, if you weren't careful and you just stopped there, you would have been tricked into the wrong answer for this problem, because you have to take account of the fact that ordering does not matter for the number of combinations among friends. In other words, if it were Dave given ticket 1 and John given ticket 2, which we counted, that's exactly the same as John given ticket 1 and Dave given ticket 2. Because it doesn't matter really which ticket. The measure of success or possible arrangements is whether they have a ticket and are in the group of 2 going to the ball game. So we don't want to double count these possibilities or arrangements, which means we have to divide by, in this case, 2, the number of overcount possibilities, which means the result is 20 divided by 2, and there are 10 arrangements that 2 tickets can be given to 5 different friends. And if you take our course, you'll likely have seen that fairly quickly in this problem by looking at it as a combination problem, not a permutation problem. This is the combination formula for choosing R objects out of n unlike objects. It's n factorial divided by n minus r factorial times r factorial. In this case, that is, n is 5 students, or 5 friends, factorial, divided by 2 tickets, so 5 minus 2 is n minus r is 2, times r, which is 2 factorial. And that in turn is 5 times 4 times 3 times 2 times 1, but again 5 minus 2 factorial is 3 times 2 times 1, so those would cancel out, and we'd just be left with 2 factorial, or 2 times 1, in the denominator, and that in turn works out again to 20 divided by 2, which equals 10, the very same answer. And you would have arrived at it much more quickly, realizing this is a combinations problem, knowing how to use the combinations formula, and assessing that order does not matter in choosing the friends for the tickets.